Okay, I've got just hand back all quiz 1 through 4. We finally got all of those done. Again, life happened to some people, and there were a few stragglers. Y'all know my policy. If life happens and you need a little break, you need to come back at it later, another week, few days, whatever it is. I'm cool with that. So we finally have all of quiz 1 through 4. I'm pretty sure I've got all of quiz 5. I graded all of your quiz 5s. And then I had about 5 left of second hour, and then the world went to hell. I was gone for like 5 days. So theoretically, we'll have everything through quiz 6 in tonight. And that should be your your quarter 3 grade. Again, if you're sitting somewhere you don't like, what are you doing different? Have you asked a question? Have you engaged on Remind? Have you come in during Spartan time, before school, after school, lunch? Have you done any of the things? Okay? Have you done the things consistently? But for the most part, everyone's doing solid. I'd say we're still at that high B, like 88 to 91 range as an average. So yay, good, awesome. What else? I think that's it, right? Oh, now that most people in my home are not vomiting, Mama Bear says she will get going on those brownies again. So, yes, your ransom is still owed. What else we got going? This weekend, I'll just be honest with you, I didn't touch a single thing remotely related to school. Nothing. Thursday and Friday, game club had our big tournaments in the library. It was fun. It was great. That's it. Y'all got 3-2 open? Let's get her done. 3-2 is normally a fairly short section. I don't feel the pressing need to move directly into 3-3. So if we get done, then you just got time to work. Okay? Because we don't have daily quiz or homework check or anything like that. Again, from, what was it, Wednesday? If you were gone on Wednesday, we went back through those last few examples from 3-1, double checked and made sure everything was solid on those. And then just kind of said, yeah, whatever, because y'all's test was interrupted. So, here we go. Well, first of all, we'll make sure. Okay. Frank works. So, and I said that chapter 3 is pretty much a rehash of chapter 7 from Algebra 2, where we're going to talk about exponential and logarithmic functions. The idea is we couldn't get anything out of exponent land, variable up in exponent, down to regular land, until we learned what a logarithm was. Logs are inverses. You remember inverses are swap x and y. So if an exponential function looky like this, and maybe had a point at 2, 4, now it's going to have a point at 4, 2. Literally swap x and y. That also means that I'm going to swap all the features of it. If it used to have a horizontal asymptote at y equals 0, a logarithm switches to what? At x equals 0. Okay? And then it's still going to use those same numbers, those same power values, where instead of starting with every single equation having, minus any transformations, where they would start at the point 0, 1, now I'm going to start at the point 1, 0. And I'm going to say, okay, we're going to say whatever the base is to the 0, whatever the base is to the first, whatever the base is to the second, base is to the third. So it's still going to use those same powers. You're still going to use those to make the graph. It's just whoop, going to do them on their side. Okay? Now, because it has that vertical asymptote at 0 minus any transformations, you look up here in all the gibberish, all the mathese, and it says if f of x is this particular exponential function where b is greater than 0, remember if it was negative, that had that weird alternating thing, and it made like a blunderbuss cone instead, then I can switch it over to log mode. And very simply it is, if I say b to the x equals y, then, or no, I want to do the thing, no, okay, I want to make sure I get my letters right here. We say x equals b to the y, then y equals log base b of x. There we go. Y'all remember the color-coded Purdy version of this? That whatever the power is, that's going to be the object of the log. Whatever the base of the exponent is, that's the base of the logarithm. And whatever the exponent was is going to be the value of the log. The easiest way to see that is with a number that we all know very well. If I had said 2 to the third is 8, I rewrite that in Logtown by saying log base 2 of 8 is 3. What a logarithm is doing is asking 2 to what power makes this thing? 2 to what power makes 8? That's what log base 2 of 8 is. So if I say log base 5 of 3125, I'm saying 5 to what power makes 3125? Do we know? 5 to what power makes 3125? Boo. Fifth. Okay. So that definition, it is also right there, right smack in the middle here. Okay. Your logarithm properties. And you notice that it says where b is greater than 0, that gets us into our third commandment of domain. Remember, the commandments of domain. Mathocles comes down from the hill. He has the tablet written by the gods, and it says, number 1, thou shalt not divide by 0. Number 2, thou shalt not take even root of negative numbers. And number 3, thou shalt not take log of any base of a non-positive number. Because now it's going to have that vertical asymptote at 0, meaning it doesn't ever have 0 as a domain. I can't take log of 0. Y'all got a calculator in front of you. Try log of 0, and it says, meh, can't do that. Try log of negative 2. Meh, can't do that. Okay? That is one of the commandments of domain. So these are the 3 that you've gotten from algebra half all the way through algebra 2. But now that we're talking about logs, this one is live. Okay? So evaluating the logarithms, it's pretty simple. You take that definition. This is asking 3 to what power makes 81? Well, 3 by 3 is 9, by 3 is 27, by 3 is 81. So 3 to the 4th makes 81. Now sometimes you got to do a little more thinking. 5 to what power makes the square root of 5? Right? You got to remember rational exponents. 5 to what power makes 5 to the 1/2? This is also called the one-to-one property of logarithms, where if they share a base, you just set their exponents equal to each other. 5 to the thing equals 5 to the thing. Well, thing better equal thing. It's just common sense. Okay? Now there's a purpose behind it, and we'll get that in 3-4 when we talk about solving these things, but that is the idea. It's saying this base to what power makes this thing. You just put them in that order. There you go. Evaluate. Figure it out. You're definitely going to want to do it with the properties, not with just, hey, I can type this in my calculator. Because if you don't know the properties, then solving the equations gets to be a big mess. 3 to the log base 3 of 1. Yes, there's a logarithm in the exponent. And you got to think about what that means. I would recommend evaluating the exponent part first. Okay, they should be fairly quick. The first one, 9 to what power makes 81? Most of us know that's just 9 squared. But do you know that you can write that as 9 to the x equals 81 and then start using your properties of exponents to break it up? Call it 9 to the x equals 9 to the second, set x equal to 2. Do you know that you can also call that 3 squared makes 9 to the x is 3 to the 4th? Well, 2x equals 4, I still get x is 2. And this idea that you might have to break up the base into its prime factors and use exponents on them is going to come in handy in a quick while here. So either way, it's 2. This one, evaluate the exponent first. 3 to what power makes 1? 0, right? Anything to the 0 power is 1. So this is 0. Okay, take 3 to the 0 power. 1. And it leads us into this logical property. So this just asked, 3 to what power makes 1? Okay, take 3 to that power. What are you going to get? What if I said 3 to what power equals 11? Some number. Okay, take 3 to that number. What will you get? 11. Like, common sense. If I kick you in the shin, you will cry. I'm about to kick you in the shin. What's going to happen? You're going to cry, right? Okay? Unless we got soccer players, then your shins are like made of just fractured bone and scar tissue, and they can repel an invasion. Okay? It's this idea that whenever a base of an exponent and the base of a log are the same, they cancel. And you just get whatever that object is. That works in reverse as well. If I said log base 3 of 3 to the 5th, I'm saying 3 to what power makes 3 to the 5th? 3 to the what makes 3 to the 5th? Well, 5. Duh. Whenever the base of the log and the base of an exponent are the same, they cancel out. And that works in forward and reverse. Okay? Which is properties. Okay, those are properties that you're going to get. The two that they use here are common logs and natural logs. The common log is base 10 because that's what our entire number system is built off of, is digits of 10, place value of 10. So it makes sense that we would have a logarithm that is purely based in that system, in that base. And the properties are, well, maybe you need to write the note to yourself if you don't remember it. If I don't see a base on a logarithm, I assume it to be 10. Just like if I ever saw a radical without an index, I assumed it to be 2. Well, now if I ever see a log without a base, I assume it to be 10. They're saying log of 1. Well, 10 to what power makes 1? So, if you need to write next to this, that's log of any base of 1 is going to be 0. Any base, doesn't matter what it is. This is just giving you for the logarithm of common base. Okay? You see again, the object of the log and the base of the log were the same. So if that's kind of like a 10 to the first, well, they would cancel out and I would just get 1. If I ever have log base b of b, they'll cancel and I'll just get 1. Again, 10 to what power makes 10 to this power? Well, that power, x. Okay, so that's, again, any base. Log base b of b to the x is just x. They will cancel. And the reverse of that, they say, again, there's a little bitty 10 right there. The base of the log and the base of the exponent are the same. They'll cancel out. So I can say b to the log base b of anything. Those will cancel and I'll get that anything. So that's written with just whatever base. The properties they gave you are specifically for common log. We should know that works for every base. Okay. Why do they have that on there? Right? Log base b of x. I can't take the log of a non-positive number, so I have to specify that it is greater than 0. 0.00000000008. Yeah, that works. But 0 itself does not. And the reason is I can't repeatedly multiply together something to make a 0. And then we learned about e. ln of x is log base e of x. Okay, when something happens so many times, it gets its own name. Okay, when I have to redirect the front row full of goobers on a daily basis, then I just put them over on the board of shame. Okay? Last semester's Algebra 2. Okay, when something happens enough times, it just gets its own special name. Okay? How many of you in your friend group, it's like, yeah, don't do it, Jack. Like, you just know Jack does this thing. He is known for this thing. Therefore, we will say pulling a Jack whenever someone does the thing. Okay? Well, whenever I have a log base e, well, e happens so often, they gave it its own name. natural log. And this really bothers some kids that this is natural log of x. They're like, why isn't it NL, not LN? Some kids just, that bothers them. Think it's French. Log au naturel. Okay, I don't know. But ln is log base e. So it's going to have all those same properties. Well, this is a base e. E to the 0 is 1. E with e cancels. E with e cancels. E with e cancels. Okay, it works with any base, so it also works with a special base. It's just going to have its own pretty little term, ln, natural log. And over to the side, you see their the graphs of them. Again, it's just an inverse. They just swap x's and y's and make the graph. So, evaluating them. I'm going to use those properties. Poke. Now, most of the time, we would see that decimal and we would think, well, let's just jam it into the calculator. Be smarter than that. What place value is that 1 in? So that's log base 10 of 1 tenths, hundredths, thousandth. Could I write 1,000 as 10 to a power? So this would be 10 to the third. And then because it's on the denominator, this is really log base 10 of 10 to the negative third. Well, we got that property that says whenever the base and the object are the same, they cancel. Remember, I can't take the log of a number less than 0. The number I'm actually taking the log of is greater than 0. Perfectly legal. Okay, again, I'm going to take 10 to some power and make 5. Okay, now take 10 to that power. They're going to cancel. Just write 5. When it comes time for a daily quiz or a quiz, and it'll say something like evaluate the logarithm, but show the properties to receive work. So I know you don't just dump it in a calculator and that's what it told me. It's something as simple as, can you come up to this and say that? Okay, you've crossed out the log base 10 with the base of exponent 10 to show me you understand the property. Okay, sufficient work. Log of 26, sometimes 26, like other numbers, cannot be written as a base 10. So you just got to go to your calculator. So go find your common log of 26, poke the button, I get the thing. Now this is an irrational number. If we're solving equations, I would write that as literally just log of 26. That would be my answer. That's as simple as it gets as an expression. But if I'm evaluating it, then I'll say it's approximately 1.415. Because it is an irrational number and I'm cutting off part of its value, I need to say approximately, not equals. And log of -5. You can't do that. Okay, it doesn't work. It breaks our third commandment of domain. So when they ask what this is, I'm just going to say no. Empty set, non-real answers, doesn't exist. Okay, so this is just, can you use the properties to evaluate a logarithm, yay or nay? Go!
is a great question. I got questions about a -0.
Simplify the object of the log before trying to do it. And this is why I'm a very big proponent of the idea for year-round school. Most other countries will do year-round school, and they'll have a 3 to 4 week break in between quarters. So it's like it's a full quarter. At the midterm, you get like a week off. And then after the quarter, you get, I think it's like 3 weeks off or something. Leads to a lot of loss of retention.
I don't want to hear it. I know that happens.
Before we start arguing about summers and time off of school, did we actually do them yet?
Of course we did. I did the majority. I don't want to break out in my
Okay, don't overthink them. 10 to the fourth is 10,000, so base 10 of what makes 10,000 is just 4. Okay, this one's, even though I could write that as 81 thousandths, unfortunately 81 itself can't be written as base 10. So I'm going to have to go in the calculator no matter what. Press the buttons. What be it? Negative who? 1.0 mutter. 91. Okay. Log of -0. Y'all, thou shalt not take log of non-positives. -0 is still 0. But you can't take the log of 0, whether it's positive or negative. So just no. Okay. And the base and the base match, so they cancel out and you get just a 3. Okay. Again, there's very little in this chapter that is different than what you did in Algebra 2. Okay? Same difference, right? It's still the properties of logs, it's just now it's base E instead. If the base of the log and the object are the same, they cancel. If the base of the log and the base of the exponent are the same, they cancel. Thou shalt not take log of any base of a non-positive. And e to the something makes 4. I don't know. So I'm going to queep. And we're going to go to ln of 4. It assumes that I'm done if I never press it. And I will give the approximation. This is the simplified expression, but the approximation is 1.386. Okay? So if it asks you to simplify as an expression, you'll just leave it as ln of 4. Well, you could write it as 2 ln of 2. We'll get to that tomorrow. But I just write the decimal approximation, call it good. So, same thing, new base. It's the remix. Those 4. Three, four, six, six. Okay, two of them you just got to jam it into a calculator. Two of them you can get it with the properties. On 4D, remember, I can't take the log of a non-positive. 9 is positive. The negative is out front of the log. So that just means you negate your answer. Okay?
Oh, so you just do it like normal and just go negative?
Yeah.
Okay, that.
Okay, the negative is not attached to the 9 itself. So, again, these are all properties out of Algebra 2, just reviewing them. I want you to take a look at those 9. Are there any of them that are a little bit sketchy for you? Any of them you want to look through? You're not sure about? Wow, that's like 8-bit Mario.
Yeah.
But isn't this E of a thing?
Oh, yeah. And what do you do?
So it still just cancels in 0.014x. That's just it. We're so used to solving and evaluating where we get a number as an answer. You can have an answer that still has a variable in it. That's okay. Okay, I heard 4 might be a little iffy. Ah, no, bad. You take it in stages. How about that's 2 times ln e to the 5th? Well, this part cancels, and that's just 5. So it's 2 of them. Okay? Now, when we do our properties tomorrow, y'all remember the whole, like, get in the choppa thing, right? Like, that you can bring exponents in and out of exponent land and coefficient with logarithms. It's a property we'll talk about tomorrow, but this is ln of e to the 10th. Well, that still cancels and gets me 10. So I can get to that 10 2 different ways. Okay. All right, the graphs of them. Again, we're going to have transformations. We're going to have our analysis. We're going to have all that stuff. We're going to use our properties or our power values. It's just now they're all on their side. So I don't see anything grouped in with the x. So there's not going to be any form of horizontal translation. So I'll start with a horizontal or vertical asymptote at x equals 0. Thou shalt not take log of non-positives. After that, I'm just going to use all the powers of 3, but they're going to be on their side. To show you what I mean, what if I did, y'all remember inverses, right? If this is y equals log base 3 of x, swap x and y, Use your definition. 3 to this power makes this thing. So these two are inverses. So if a normal 3 to the x looks like 1/9, 1/3, 1, 3, 9, if that's how a normal 3 to the x looks, I take all of those points. And if this is at 2, 9, then the logarithm base 3 of x is going to be at 9, 2. It's going to swap. 9, 2. Instead of 1, 3, it's going to be at 3, 1. Instead of 0, 1, it's going to be at 1, 0. Instead of -1, a third, it's going to be a third, -1. Instead of -2, a ninth, it's going to be a ninth, -2. And you get, it curls along this asymptote, and it's still a creeper function. It's just sideways. Okay? It's still using those powers. Something to the 0, something to the first, something to the second. It's those same things, it's just they're on their side. Instead of going from y equals 0, they're going from x equals 0. Okay? So, all that, poke. So that's just showing you where it came from. Is this the describe and analyze thing again? Find all the stuff about it? Okay. Domain. Where are we allowed to exist for the x's? Greater than 0. Range. Yes. Because this is the inverse of 3 to the x. If 3 to the x has a domain of all real numbers, this inverse is going to have a range of all real numbers. If the the range of 3 to the x is 0 to infinity, then the domain of its inverse is 0 to infinity. Just swap everything. Okay, what else? X-intercept. Oh, we do got one this time. 1, 0, but this one now won't have a y-intercept. If I asked for, what else? Continuity. Kind of like our radical functions. It is continuous where? 0 to infinity. So let's say it's continuous at 0 to infinity. Don't say infinite discontinuity, because there's not a asymptote in the middle of the function breaking up the domain. It's just that's where it starts. Okay, what else? Probably intervals of increase and decrease. Does it ask for symmetry? Oh, there we go. Limit of my function as x approaches. Limit of my function as x approaches. That is in the wrong spot. Okay. And the asymptote, there's a vertical asymptote at x equals 0. Okay, so where's it increasing? As I go left to right across the paper from 0 to infinity, right? There is no decrease. As x goes to infinity, so do my y's. Do you remember how to handle the end behavior on the left side? Okay, since the domain is from 0 to infinity, as I approach the left end of the domain, so I'll say as it approaches 0 from the right. Remember that? We did it with our radicals, with square roots. As I approach 0 from the right, where does the y go? All the way down. Okay. So what do you think is going to happen when the base is a proper fraction? I'll tell you the asymptote's still the same. Think about the powers of 1/2.
Don't they go like this way?
Yep, it's going to be a vertical reflection of it. Where now I'm going to have 1/2 to the 0 is still 1. But 1/2 to the negative first is 2. 1/2 to the negative second is 4. 1/2 to the negative third is 8. Because 1/2 to the first is only a half. 1/2 to the second is a quarter, is an eighth, is a 16th. So whenever my base is a proper fraction, it's going to act like a vertical reflection. All right, domain, range, x-intercept, y-intercept, continuity, increase, decrease, limit of g of x as x approaches. And my vertical asymptote. Okay, domain.
Use 0
That hasn't changed. Make sure you're using 0 with parenthesis, not a bracket, because it can't actually be a log of 0. Range is going to be all real numbers again. X-intercept is still at 1, unless I have a translation left and right, yes. Okay, no y-intercept. The continuity is still continuous at 0 to infinity. Now things change. It is always decreasing, never increasing. The left end behavior is still 0. I will still approach it from the right, but as I hit that asymptote, where are the y's going? Off to positive infinity. As we head all the way to the right, x's go all the way to the infinities. Where are the y's headed? Negative infinity. And that vertical asymptote is still x equals 0. Okay? And anyone who's paying attention, we've run across this how many times in the last few weeks? You look right below that. It's the same thing, right? Okay? There can't be. Like by definition, because it's the inverse of an exponent. Exponents have horizontal asymptotes, so logarithms have to have vertical asymptotes.
Oh, yeah.
So I don't see a need to do both. 5B. Graph it and tell me stuff. Message from Mama Bear. She says brownies are in the oven. So. Okay. These should be quick if you know your powers. Because again, from that asymptote, you are moving powers of 3. Because it's 1/3 as a base, you're going to have that flip, that reflection to it again. And then for the analysis of it, I'm going to get lazy because it was right there on your paper. Exactly the same as the one right above it.
If you have like a 3 in front of the log, is that like the stretch of it?
There is a vertical stretch to it, yes. Now remember, it's a vertical stretch. Okay? Real good question here. What would happen in a vertical stretch? Remember, vertical stretch, not horizontal. So nothing happens to how far away from the asymptote those points are. What happens is these points would be further apart vertically. I would start here, and let's say there was a 3 in front of it. Now, instead of going down 1, right 3, I'll go down 3, right 3. I'll go down 6, right 9. I'll go up 3, right a third. I'll go up 6, a ninth. And you can actually see that it's a vertical stretch. Yes?
Is where the point on the x-axis right now, is that considered a vertex?
Kind of like our vertex or inflection point. Just like on an exponential, we had 0, 1 as kind of our starting point. We're going to have 1, 0 as our starting point here. Yep. Okay, so that's a good question. Again, all the stuff, it's right there. Oh, they have on there about extrema because there's no maximum or minimum. Yeah. And then transformations. Transformations are blah, blah, blah. Do the same thing we've been doing. Maybe we need to write, this would probably be a good spot to write it. Y is log base b, whatever b is. Okay, remember every time you have a new base, it's a new parent function of and all of that stuff does what it's been doing. A, what's A do? Vertical dilation. If it's greater than 1, it's a stretch. If it's less than 1, it's a compression. If it's negative, you get a vertical reflection or reflection in the x-axis. Ooh, it's log base b. We got to change our letter here. D? Kind of like B. It's B's bass-backwards cousin. He's from Georgia. Okay. That I'm still going to have, it's where our B normally is, but remember we have a different, B stands for base in these. Okay. It's whatever is there. You could call it whatever you want. All right. The transformation form of this doesn't matter. In what I label them, it's just this spot is still going to be a horizontal stretch and compression by the reciprocal, horizontal reflection in the y-axis. That stuff's still going to happen. They don't do that very often with logarithms. But if I'm negating the input is now allowed to be negative because I'll be negating it. And that's what allows it to go that way. H is still bass-ackwards land. If it says -5, I go right 5. If it says +5, I go left 5. It's my horizontal translation. And K is still my vertical translation, up and down. That's why we beat these to death in Algebra 2, because you keep seeing them. Okay? Same stuff. So, if I do, I'll do C. Okay? So normally, what's the base on this? Okay, common log. So normally I'd have vertical asymptote at x equals 0, but this has a translation left 2. Okay. I should not have to talk over you. We have a horizontal translation left 2. That means I move the asymptote. All of my points are derived from that asymptote. So I'm still going to use to the right of the asymptote 1 as my initial point. Because 10 to the 0 power is 1. So I move 1 away from the asymptote. 10 to the first is 10. So when I go up 1, I will still go over 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then 1/10. I know those are wrong. Okay. So I would see a curve like that. But we had something else that happened. A vertical stretch or dilation I don't care what you say, by 3. So that means the vertical spacing between these is 3 times taller. I'm not going to go up 1 and write 10. I'm going to go up 3 and write 10. I'm not going to go down 1 and over 1/10. I'm going to go down 3 and over 1/10. And when I look for points on your graph to see if you are actually graphing this right or if you're just winging it because it's what your calculator screen looks like, those are the points I'm looking for, those 3. Okay. And then connect the dots. And you see how it is a little bit taller than what would have been a normal log of x because it's vertically stretched. With that, you see how close that logarithm gets to the asymptote? 3 log of, what was it, x plus 2? Yeah, x plus 2. Look at the graph. You got to be smarter than the calculator. Okay? We know that there's an asymptote right here. But it gets so close to the asymptote, and the calculator knows it's not supposed to exist back there, that it stops showing it because it's only got so many pixels, because it's using the same screen that it's been using since 2004. Okay? So when it comes time for a quiz, make sure you are smarter than the calculator. If I see this and nothing below it, that tells me you have no idea what's going on. I would circle the missing part and mark one off. Okay? You got to know what the graph is doing. Some of you just got back quizzes 1 through 4, and we'll see something like that where a portion of the graph is circled and there's nothing there. Well, it's because you didn't finish the graph. Okay? So be smarter than the calculator. Calculator's only got so many pixels, but you can be high def. Here, I'll do 6C as well. My vertical asymptote would have been at 0. I have a horizontal translation, left 4. 1, 2, 3, 4. My initial point would normally be on the x-axis, but this has a vertical translation up 3. So that initial point is going to be here. And then I use powers of what? E. Remember? Log E. Okay, ln is log E. So we'll go up 1, right E. How much was E? Okay, 2.72-ish. I'll go up 2 over, what was E squared? Yeah?
It's over 2.7, right? You only did 1.7.
From the asymptote. Bring it. Bring it. I kind of slept. Okay?
I kind of slept.
Um,
I'm doing good.
From the asymptote, I actually yelled at a kid in my game club Discord. They were pinging me at like 3:30 asking a question. Like, I know what do not disturb is, so my phone is quiet. But why are you up at 3:30 on a school night? Children. 1, 2, 3, 4, 5, 6, 7. It was like 0.38 or 0.4 or something. Is that enough to see the curve? Do I know that this is going to be a itty bitty fraction? Well, there we go. Connect the dots, got your graph, and I would say this is a horizontal translation, left 4, and this is a vertical translation, up 3. Don't have to write a dissertation, but you are at least got some big kid words, even if they're in abbreviations. Okay? The other 4, because we need practice with our powers. The other 4. I did 1 from the got it because it's ln. Okay, these other 4. A, B, 6A, 6B. Get them.
So, the thing you were talking about?
Well, yeah, but in the shooters channel, I don't know. Nora was having like a 3 a.m. attack of conscience that we used the word shooter. We have a channel in our game club Discord for like shooter games. Should we even call it shooters because it's a school server? Like that's literally the genre of the game, so it's cool. Also, if anyone's going to have a problem with anything in that server, it's going to be me advocating for human rights because we're in South Dakota.
Negative, like, can they negate each other? Is that like a thing?
No, because one is attached to the log and the -5 is a separate term.
So it's just two negative ones. So just it'd be one.
So it'll flip.
Because it's a reflection.
It's in the A spot, vertical reflection.
Yeah, but would it start at -5 then? Positive.
Well,
Or
yeah,
wait.
because you're going to have a vertical translation down 5 as well.
Yeah. Fix this.
Remember, you really, really want to have points on here. Your graphing calculator is not going to be too much help because most of these are going to be missing part of the graph. And depending on the addition of the calculator, it might just be a pixelated line. Now, graphing by points from the table in the calculator, that'll work.
Do you use less like
Just like we did with some of those rational functions, you can tell me the transformations and then plot by point. Usually the first error you see in a table is going to be its vertical asymptote. I'm betting the first one is okay. Just move it left 4. Use your big kid words. Say there is a horizontal translation left 4. Powers of 10. 1/10, 1, 10. So on a graphing calculator screen, that's going to look pretty sharp, hook right. This one. Normally, I would start with a point at 1, 0. I got two things going on here. A, vertical translation down 5. 1, 2, 3, 4, 5. That point is still there. It's just my vertical reflection says instead of doing this, I'm going to do this. And it's still going to have that point 1, -5 right there. So it's kind of like when I would reflect about a vertex, the vertex wouldn't change, it's everything around it. Well, I'm going to reflect around that green dot. And I'll still use my powers of 10. So 10 to the 0 is 1, 10 to the first is 10. That's a 9. Isn't 10 right off the map? And 10 to the -1st is 1/10. And I get that graph that just whoop, hooks to the right real fast. Okay? So it's a vertical reflection around that initial point. And then again, I'll say a reflection in the x-axis and a vertical translation down 5. Okay, so state your transformations and graph. Note on this one, if it asks me for the domain, now it's going to be from -4 to infinity. Okay, our LNs, same thing, it's just a base E. If I go right 6, 1, 2, 3, 4, 5, 6, and then powers of E. E to the 0 is still 1, so 1 away from that asymptote. E to the first is still 2.72-ish. E to the second is still 7.3-ish. So I'm still going to have that graph, it's just I don't see very much of it because I just don't have enough room. And then I'll say horizontal translation, right 6. Okay, this one. Again, I've got my vertical asymptote. My initial point will be moved down 2. So vertical translation down 2. Be careful when you make the rest of your points. What is that 0.5 doing? So remember, it's in the A spot. A is vertical stretch. So I'm still going to use the powers of E. It's just instead of going up 1 and over E, up 2 and over E squared, I'm going to go up a half and over E. Up 2 halves, or 1, over E squared. So when you have a vertical compression on these, up 1 or up a half over E, up 1 over E squared, 1, 2, 3, 4, 5, 6, 7, and some change. What happens is this thing takes off extremely fast. Okay, it's almost gonna look like you drifted around the corner heading into the school parking lot. Okay. So, take a look at all three. Are there any of them that are a little iffy to you? 10. 10 is actually not even logarithms, it's our exponent stuff from before. I would take powers of 4. I would separate my negative from x minus h. We ran into that a few times now. Remember that b value, or I guess we got to call it like C or D or whatever now. That horizontal reflection, stretch, compression number has to be separated from x minus h, so make sure you factor it out. And then, normally, what are my boxes going by here? 3s? Oh, powers of 4 and then going by 3s? God, you suck. Okay, so normally, I would have a horizontal asymptote at 0. Anything to the 0 power is 1, so 1 above it. What I'm going to change now, come on you, is, okay, that thing is going to get moved right to, but then it has a horizontal reflection. So now when I go right 1, I'm not going up 4, I'm going 1/4, 1/16, 1/64. I'll go left 1 and up 4, so there's 3, 4. I'll go left 2 and up 16, 12, 13, 14, 15, 16. It's like 1 above that. I know it looks like it's online, it's above. Okay, so this is just mastering those transformations from Algebra 2. Horizontal reflection. It takes this graph and moves it that way.
Because it would be 4 to the x, would be the first.
So now instead of 4 to the first, it'll be 4 to a negative first. Okay. And the last thing is blah, 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 blah. Jam it into your calculator. Because, yeah, I can use the properties of exponents to simplify these things. I can use properties of logs to simplify those. But odds are I'm still going to have some decimal component that I can't use properties of logs on. And I'm going to need my calculator anyway. So this is more about, do you understand how to read a word problem? Okay. Intensity level of sound measured in decibels can be modeled by equation. W is the intensity of the sound. W sub 0 is a constant. When they tell me it's a constant, that means I can just plug that number right into there. If the intensity of a sound of a person talking loudly, so that'd be me right now projecting to a classroom, is about this many watts per square meter, what is the intensity level in decibels? Okay, 10 log me yakking and it says W sub 0 is this constant, 1.0 times 10 to the negative 12. So here's what I mean about they want us to do a little bit of simplifying first, but you're going to use your calculator anyway. Y'all remember your rules for exponents? Subtract it, right? So negative 8 minus negative 12. Oh boy, we are rusty after the weekend. Negative 8 minus negative 12. Positive 4, okay? So 10 log of, and then this divided by 1 is still itself. Yeah, I can simplify it, but do you see how you're just going to have to use a calculator anyway? Because I can't write 3.16 as a base of 10. So then I just jam it in the calculator. So 10 log, parenthesis, 3.16 by 10 to the 4th. And it says About 45 decibels. .997 decibels. Okay. If the threshold of hearing for a person with hearing loss is 5 decibels, meaning if it's below 5 decibels, if the intensity is lower than that, they just ain't going to hear you. You know, think about grandma turning the TV up about 19 times. No one else in the room can have a conversation. Okay. It says, will this sound be audible to that person? What are they asking me to do? Plug and chug. This is the intensity of the sound. Plug it in here and see if it evaluates at over 5. So I'm grab my calculator, say 10 log of, oh, I don't need that extra parenthesis, 2.1 times 10 to the negative 12th over whatever that constant was, 1 times 10 to the negative 12th. Do you see why they want us to clean this up? Anything over itself is 1. So I could have just said 10 log of 2.1. And we'll double check that, 10 log of 2.1. Okay. So this particular sound comes out to be about 3.2 decibels. Nah, grandma ain't gonna hear it. What? What do you say? No, lunch is later. Sounds in excess of 85 decibels can cause hearing damage. Determine the intensity of a sound with an intensity level of 85 decibels. So now I know 85, 10 log of thing over 1 times 10 to the negative 12th. How can I solve to get x? I'd say first stage, isolate the logarithm. Just divide by 10. Here, I'll move this up so we can actually see what we're doing. Really? Okay, so we'll have 8.5 is log of x over 1 times 10 to, you know what, how about I clean that up? 1 times anything is that anything. What can I do with a negative exponent? Put it up top. Just divided. Yep. Do I have a way to get rid of logarithms? Their definition, perhaps? What's the base on this log? So it's asking 10 to this power makes this thing. So 10 to the 8.5 is 10 to the 12th times x. Oh, but there's an x that isn't at a base 10. I would just divide. Just get x by himself by saying x is 10 to the 8.5 over 10 to the 12th. subtract the exponents, 10 to the negative 3.5. So x is, if I want to write it in their scientific notation, 1 times 10 to the negative 3.5. Or I'd grab my calculatron and say 10 to the negative 3.5 is about this much. Y'all remember what e negative 4 does? Incorrect. We're going to move it 4 places that way. 0.123316. What is it? Watts per square meter? Okay. So it's just, hey, do you know the definition of a log? Can you plug things in your calculator? That is the word problems for this section. Okay. There you go. Donezo. That's it.